First, differences of linear and nonlinear relations. Which of these relations represent linear relations or nonlinear relations? If I take a ruler and I swing it around and I try and make it fit on top of the graph, I should see that I can line up all my points along the graph or along the ruler. So the ruler ends up having a nice straight line along the points. Of course, I'm having difficulty making the ruler behave for me, but you can see that it's going to be a straight line along there. Same thing here with this one. If I can get the ruler to behave, it will end up giving me a straight line along all of the points on the graph. And if I look at the last one over here, there's no way that my ruler can pass through everything on that graph. So what does that mean? When something's linear, I can draw a straight line through all of the points. If it's nonlinear, I can't do that. Now, if I graph this data here, can I tell from looking at the equation? If I plot some points, x is -3 and y is 2. And then I go to -2 and 1 and -1 and 0 and 0 and -1. And if I were to get a handy dandy ruler out, I'd be able to draw a straight line through all of those points. When I do the same thing for these points, -3, 2, oops, that was -2, 2. So -3, 2, sorry guys, this is just a rough sketch. -2, 6 goes up there, -1, 10. I go up there, and then I have 0, 6. Wait a minute. My points are coming back down again. So I went up, and then I started to come down. It's nonlinear. So how are these tables different? If I look at the data in table A, I can see that as x increased by 1, the y values decreased by 1. And in the table B, as x increased by 1, y increased by 4. And then it increased by 4 again. Oh, okay, so maybe it has nothing to do with the pattern. Oh, wait a minute, now it decreased by 4. And it decreased by 4 again. What we were looking at there in each of those, when we found those -1s in table A and the +4s and -4s in table B, were first differences. They were the differences between consecutive values of your dependent variable. So when your independent variable increases or decreases by a constant, and you find the differences between the values of the dependent variable, that's what's known as first differences. And first differences tell us whether a function is linear or nonlinear. So if the first differences are constant, the relation is linear. If they're not constant, the relation is not linear. So how do I determine them? I always do y2 minus y1, and I could do y3 minus y2, and if I go back here, this value here would be y1, y2, y3, y4, y5. So you would be subtracting those values to try and find a constant. Assuming, of course, that your relation is linear. If it's not linear, you won't find a constant.